A message sent from beyond space, a world that defies all expectations and a dash toward a different star. What if we held every belief that the universe is about to be turned upside down? The JW Identifications, or James Webb Space Telescope, has shed light on mysteries so amazing that they might transform the very foundations of existence. But is Proxima B genuinely a new Earth or a dangerous trap in the vastness of the cosmos? The James Webb Space Telescope, widely considered to be the most sophisticated orbital device, has recently shifted its focus to one of the most compelling exoplanets ever identified. Proxima B, this remote realm circling the red dwarf star Proxima Centauri, has captivated researchers and space enthusiasts of all kinds since its unveiling. Now, with JWST's unparalleled abilities, we are finally receiving an intimate view of this perplexing planet, and the revelations are nothing less than astonishing. Proxima B was first discovered in 2013, but it wasn't until JWST arrived on the scene that we could comprehend exactly what resides on this distant world. The telescope's capacity for infrared astronomy has allowed astronomers to investigate Proxima B's atmosphere, uncovering details that were once invisible. Their discovery has sparked both enthusiasm and unease. Consider that Proxima B revolves around its star at an incredibly close distance, only 7.3 million kilometers away, under 5% of the span between the Sun and Earth. This proximity signifies that the planet goes around its star in merely 11 Earth days. What results is even more captivating. Proxima Centauri, the star it encircles, is a red dwarf. Contrary to our Sun, which is relatively temperate, red dwarfs are known for their violent behavior, frequently emitting potent stellar flares that can dramatically affect circling planets. The narrative advances even more compellingly. The most vivid portrayal of Proxima B yet has been issued by JWST, revealing some startling attributes. For instance, the planet is about 30% larger than Earth, indicating stronger gravity at the surface. Yet, perhaps most surprising, Proxima B is tidally locked with its star, meaning one hemisphere is perpetually illuminated while the opposite side remains in endless darkness. Imagine a world where daylight never ends on one half while the other is lost in infinity. Tidal locking results in an extremely severe climate for potential life. The star-facing side would be seared by unrelenting radiation, whereas the dark hemisphere would be a frigid wasteland. This prompts a pivotal question: could life endure such extreme conditions? The odds appear low. Yet, biology is often more adaptable than we presume. Nevertheless, the difficulties do not end there. Proxima Centauri itself presents a major hazard to Proxima B's habitability. JWST has shown that the star is significantly more active than earlier believed, with powerful magnetic fields that result in massive stellar eruptions that cover Proxima B in extremely active radiation. Indeed, a flare spotted in April 2021 was 100 times more intense than any our Sun has ever recorded. Such an immense burst could erode the planet's atmosphere, putting it in contact with the merciless vacuum of space. Some scientists assert that the proximity of Proxima B to its star and its frequent solar eruptions make it an unlikely candidate for supporting life as we understand it. However, others contend that life could adjust to these unpredictable extremes. Could life on Proxima B have evolved mechanisms to endure such unstable circumstances, or is the world doomed to remain a desolate, lifeless rock? As we persist in using JWST to examine Proxima B, there are bound to be additional mysteries that surface. But there is one certainty. This minuscule planet, just 4.2 light-years away from Earth, is far more intricate and enigmatic than we once conceived. Is Proxima B the key to redefining life's boundaries in the cosmos? If so, what repercussions does that have for our search for life on other planets? One of the most sensational disclosures from JWST is Proxima B's possible lack of an atmosphere. The incessant assault from Proxima Centauri's radiation, coupled with the planet's tight orbit, means it is frequently impacted by stellar wind and high-energy particles over epochs. The planet may be stripped of its atmospheric envelope, leaving it exposed to the ICIV twist is as follows. Some researchers propose that Proxima B might still harbor a thin atmosphere, likely composed of heavier gases such as nitrogen or carbon dioxide, which could provide some protection from stellar radiation. JWST has granted us the highest point of view of Proxima B's terrain, and what it reveals is both enthralling and puzzling. The surface looks rough, Earth-like in structure, but with important distinctions. For example, the Proxima Centauri-facing hemisphere is likely burned by constant heat, forming a sterile desert landscape. Meanwhile, the dark side is likely a frozen desert, with temperatures plummeting well below any recorded on Earth. Yet, the most fascinating prospect lies in the narrow transition zone known as the twilight zone between these extremes. This line where the sun meets night could harbor more moderate conditions where liquid water might exist. The presence of liquid water, of course, is one of the fundamental requirements for life as we know it. Does the twilight zone hold a hidden niche in which life has succeeded in emerging despite the hostile surroundings on the rest of the planet? Another exciting potential has emerged as scientists explore the possibility of water on Proxima B. If there is water, it would probably form ice on the dark portion or in small, possibly vanishing, bodies in the twilight zone. However, the possibility of oceans beneath the surface, similar to those found on moons like Europa or Enceladus within our solar system, has astonished many. These oceans might be heated by Proxima B's core or by tidal stresses arising from its tight orbit around its star. If these oceans do exist, they would be excellent locations to search for life beneath the frozen crust. However, the challenges persist. Proxima Centauri's magnetic behavior is another factor that complicates the planet's environment. Recent studies indicate that the star's magnetic field could interact with the planet's interior, perhaps inducing its own magnetic shield, which could protect Proxima B's atmosphere from being entirely swept away by stellar wind, similar to how Earth's magnetosphere safeguards us. However, conditions on Proxima B are far from straightforward. The star's potent flares may overwhelm the planet's magnetic defenses, triggering abrupt and extreme changes in its surface and climate states. These insights raise even more questions than they answer. Does Proxima B generate its own magnetic field? If so, how robust is it, and how does it influence the planet's atmosphere and potential for life? Could life on Proxima B have adapted to survive under the world's harsh and fluctuating conditions? And if life exists, in what form might it appear? Would it be something completely unrelated to terrestrial organisms? Void? Or perhaps it like extreophiles that thrive in what are the harshest habitats on Earth. Despite the idea that a planet could be habitable, orbiting Proxima Centauri is alluring, the truth is much less welcoming. JWST has provided unheard of insight into the impediments to a possible life Proxima B might encounter, and the prospects are bleak. One of the most highly formidable challenges is its exposure to Proxima Centauri's intense radiation. Unlike our Sun, Proxima Centauri is a red dwarf with significantly lower mass and a far more tumultuous surface. Because of the star's proximity to the planet is always Proxima B bombarded by potent stellar radiation, including blasts that are 100 times superior to anything that can be observed from the Sun. These eruptions release a lethal combination of X-ray and ultraviolet radiation fatal to any life form akin to the people on Earth. These effects are not hypothetical. In April 2021, a incredibly potent flare from Proxima Centauri was documented, strong enough to possibly destroy any atmosphere possibly Proxima B possessed. This incident serves as a wake-up call, illustration of the threats posed by red dwarf stars which cast doubt on habitability of the planet. Moreover, regular exposure to this kind of radiation would render Proxima B's surface extremely inhospitable. Any water on the surface would quickly evaporate and the rocky terrain would be scorched by unremitting heat. The planet's dark hemisphere, despite being protected from direct radiation, would be just as unlivable because of the bitter cold. This stark contrast between the blazing day side. Likewise, the frozen night side leaves little opportunity for a long-term, stable environment. In the interim, the race to reach Proxima Centauri has already commenced. Though the mysterious signal remains from Proxima Centauri, the possibility of being physically reaching the star system has shifted from fictitious to actual science goal. The Breakthrough Starshot initiative, spearheaded by visionary scientists and supported by figures like Stephen Hawking and Yuri Milner, aims to dispatch ultra-small laser-propelled probes to the Alpha Centauri system, including Proxima Centauri within our lifetimes. The concept behind Breakthrough Starshot is daring and transformative. The plan calls for launching thousands of miniaturized spacecraft, each about the size of a stamp, that is driven by powerful lasers with speeds of up to 20% of speed of light. These will eventually crafts could arrive at Proxima Centauri in just over 20 years, vastly faster than conventional propulsion methods. The project is still in its infancy, but initiative has already won worldwide attention. Its success would represent the very first time that humans sent an object beyond the vicinity of our solar system. This bold endeavor provokes a compelling question. What if Proxima Centauri's signal is more than random noise? It could be proof that somebody or something is making an effort to communicate with us. If Proxima B supports life, might we eventually achieve establishment communication? Interstellar communication might resemble science fiction, but developments in technology and our increasing cosmic understanding make it more plausible than ever. As our exploration of Proxima B continues, one theme appears. This remote world is not just a new scientific discovery. It has the capacity to fundamentally alter our comprehension of daily life in the universe. A treasure has been opened by JWST, trove of new insights. And as we continue deeper into Proxima B's mysteries, we may find something that will last forever, alter humanity's perspective on the universe. What do you think? Should it be sent out? Message to Proxima Centauri. Can this be? Could a distant planet represent hope or first evidence of extraterrestrial life? The next chapter of humanity's the exploration of space has already begun, and the tantalizing possibility that there may be life on Proxima B, so whether simple microbiota or far more complex beings, which raises serious concerns about existence as a whole. Our quest for life beyond Earth is no longer solely about locating a new Earth. It's about determining whether life can survive in the harshest and most unforgiving circumstances imaginable. The more we learn about Proxima B, the more we realize that this is the very essence of life. Might need to be rethought. Consider extremophiles, microorganisms on Earth that thrive in the most extreme conditions known to science. They can stand boiling hydrothermal vents, acidic lakes, and the frozen wastes of polar regions. If life can evolve to thrive in such conditions in this area, so why didn't it find a method for remaining on Proxima B despite intense radiation, tidal locking, and extreme temperature swings? Imagine the life forms we eventually discover there are unlike anything else we've ever seen, conceived. What if life on Proxima B flourishes in, assuming it exists, circumstances that we would seriously consider hostile? Exploring Proxima B also sparked fresh thoughts on our own planet's future as we investigate other worlds. We learn that Earth is not, and with all of its delicate ecosystems, isolated anomaly in the universe. Our planet, on the other hand, is just one countless worlds, each with its own distinct circumstances and history in facing challenges like climate change and ecological collapse. We are reminded of how precarious our existence is. Could learning more about Proxima help us protect our planet? Can we draw inspiration from other worlds' methods, whether inviting or inimical, have evolved? As the competition to discover Proxima B accelerates, private space agencies and institutions and researchers worldwide play an ever more vital role. NASA, the European Space Agency, and private ventures like SpaceX and Blue Origin are all advancing the planet's advancement exploration with the focus on Proxima Centauri target in coming decades. If we will follow Breakthrough Starshot's success, perhaps for the first time send a spacecraft to another star system, a monumental stride for humanity. This mission would not only expand knowledge of Proxima B, but they can also act as a stepping stone to discovering other beyond, potentially habitable exoplanets our own. Beyond scientific discovery, Proxima research brings us closer to the profound realization we may not be alone. Even if life exists elsewhere in microscopic forms, it could overturn our sense of place in the cosmos. Our search for extraterrestrial life long driven by hope of contact with advanced civilizations may eventually reveal a universe with a lot of life. Life as amazing and diverse as the stars themselves. Furthermore, the idea of communicating with Proxima Centauri opens thrilling possibilities. Could we be the first to communicate with a different advanced civilization? Or perhaps others have been keeping a close eye on us longer than we imagine.